Cleo and Diana were given the same amount of money each day. Cleo spent 4/7 of her money and Diana spent 2/3 of her money every day. They then saved the rest of their money. After a week, Cleo saved $56 more than Diana. And we're asked, how much money did Cleo spend a day? How much money did Diana spend a day? Well, hopefully you've noticed a few things already. What are the things that have stood out? Well, the fact that they were given the same amount each day is going to be important. We've also got Cleo's split into sevenths and Diana's into thirds. So we're going to have to think about that. And also we've got them spending money and saving money. We're told how much they spent or the fraction that they spent. So we need to think about the fraction that they saved. That's another thing. And also here, up until this point, we've got this mention. This is talking about what happens every day. And this bit is given, this is about what happens, what's saved in a week. So we need to be careful of that, don't we? So this is what I've noticed when reading through the question. Now, let's have a look at this bit here. We know that we're going to give Cleo and Diana bars that are the same size because they're given the same amount of money. And we need to look at how we're going to split that up as well. We're told that Cleo spends 4/7 of her money. So we've got Cleo and we've got Diana, and they either spend or save their money. Okay, there's only two possibilities. So if Cleo spends 4/7 of her money, we have to think, what does she save? And that also has to be in sevenths. And the total, if we added these two together, would be one whole, which is 7/7. Okay, so what added to 4 is 7. Well, that's 3. So Cleo must have saved each day, she must have saved 3/7 of her money. And we will do the same. Let's pick another color for Diana. Diana spent 2/3. Okay, 2/3 of her money. Hers is split in 2/3. So 2/3 added to how many thirds equals 3/3, because 3/3, of course, is one whole. And that's nice and easy. That's 1/3. So we now know each day Cleo saved 3/7, Diana saved 1/3 of their money. Okay, right. So let's draw these bars. So we've got Cleo and we've got Diana, and I am going to draw Cleo a bar that's divided into sevenths. So that would be 1, 2, 3, 4, 5, 6, and 7. Okay, and we know, what do we know? We know that Cleo spent 4/7. Okay, and we can maybe shade that in, why not? So 1, 2, 1, 2, 3, 4 was spent. And that leaves us with the expected 1, 2, 3 that was saved. We could write that. There we go. And what about Diana? So remember, Diana has a bar. She has exactly the same amount of money. And Diana's is split into thirds. Now I could split this into thirds, but I want to find a way because I need to be able to have, like in all of our models, we want to have equal parts wherever we can. So if I look back at this model here, this bar that I've split into sevenths, if I split each of these into 3, okay, that's going to give me, so each of the 7 parts was split into 3. Okay, so 7 times 3, that's going to give me now 21 parts. Okay, and I've done that because I can split 21 parts. 21 is divisible by 3. Okay, and I could then have 7 of these parts would be equal to 1/3 of this bar, if that makes sense. Right, I'll show you what I'm going to do. Firstly, I'm going to split it into the sevenths that we originally had, just so that I can keep it fairly accurate. It's just easier to do it that way. Okay, 1, 2, 3, 4, 5, 6, 7, and then we split it again. So we're absolutely confident all these parts are the same. So this bar also has 21 parts. Okay, and then we'll split that into thirds. All right, so 1, 2, 3, 4, 5, 6, 7. Okay, we'll make a mark there. 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, 4, 5, 6, 7. So can you see how these parts are all equal? All right, so I can now compare things. All right, and if I get a bit of information about this bar or this bar, I can use it here. But I can also find where these thirds are that are being spoken about. Now it says that Diana spent 2/3 of her money every day. So let's get our pen, and then that's going to be 1/3. And this is the second third. So again, this is what's spent. So this must be what is saved. Okay. Right, now, have we got all of the information? Have we got it all in our bar? Yes, I think so. Up to, let's say we're up to here. So it's saved the rest of their money. That's fine. After a week, okay, so what's a week? A week is 7 days. We have to think about that. Cleo saved $56 more than Diana. Now, so that's a week. We're looking at per day. I mean, we could think about it per week and then we'd have to divide everything by 7. But let's say this model is representing what's happening every day. We then want to find out, and every day is the same, okay? This means that if we divide 56 by 7 days, we can find out what the difference is per day, how much more Cleo saves than Diana per day. So 56, if we divide that by 7, we are going to get 8. So that we know that, and we have to think, what's the difference? I mean, what does that mean? That is, and we could put that over here. Let's make sure that we've got that. It's 8 per day. All right, make sure at every stage, all these different calculations you do, you need to think again, so what did I just calculate? Where should that go into my model? What do I do with that bit of information? Okay, so again, So Cleo saved $8 per day more than Diana. So let's go back to our model and think, where is it that we can see that on our model? So this is what was spent and this is what was saved. If we sort of look at the model backwards from this end, so it's all even. Let's say we've got, this is all the same. So up until here, they've got, this is the same amount spent. And it's here that you can see the bit that's different. This is, this represents the more that Cleo saved per day. And we now have a value for that. We've got a value that's $8. Okay. So we could do it up here too. This is $8. And we can divide 8 by 2 and we get 4, of course. That is going to give you the value of each of these parts and all of the rest of the parts, of course. So, well, now we've got a value for everything. I think we can work anything out we like. So it asks us, how much money did Cleo spend a day? Well, this is Cleo. What did she spend? Well, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So she spent 12 of these parts. So that's 12 times 4, because each of them has a value of 4. Could write 4 in all of these parts. Okay. So what is 12 times 4? Let's just write it down here. 12 times 4 is, of course, $48. So that is what Cleo spent per day. Let's pick a different color. So there we go, 48. And what have we got? We have got for Diana, what did Diana spend per day? Well, we know that, what was that? 7 and 7, that's 14. Yeah, and it was 2 more. So that's going to be 14 times 4. Okay, or what's another thing you could do? You know that she spent, that Cleo spent $8 less. So Diana spent $8 more per day. So you could also do 48 plus 8 is going to equal the same amount, which is, of course, 56. Okay, it doesn't matter which way around you do it. Your model makes it clear to you that both would work. And we can put that answer in, 56. Okay, so, and if we just have a quick look at these fractions again, so hopefully what you are noticing then when you draw bars like this is what we were doing was converting, the, these were originally sevenths. Okay, so what did we have? Let's say we had 4 sevenths and we had 2/3. We wanted to be able to compare these amounts and make them all part of the same model where all of the parts were the same. So we had to find a denominator, all right, that we could convert these into. Okay, and 3 times 7 is 21. That's the easiest thing to do. And so what we've done is multiplied 7 by 3 gives us 21. And if the 7's multiplied by 3, the 4 has to be multiplied by 3. So that is 12. And here we have, that is multiplied by 7. That is multiplied by 7. So we get 2 times 7 is 14. and 3 times 7 is 21. So this is just us making equivalent fractions with the same denominator. And that's basically what we're doing here in the models. Okay, that's all we were doing. Well, hopefully that makes sense.